Srirangan Sudarshan, and this is my recording for Lab 1 charge tapes. In this lab, we aim to analyze and observe the interactions between charge tapes with one another and with other objects, and simulate this as a model using GlowScript to calculate the charge on each tape as well as other values. Now, the main results here include the fact that the tape develops a positive charge of about 10 power negative 8 coulombs, and it has an electron deficit of about 6.26 into 10 power 10 electrons. The electrostatic force of attraction or repulsion is a very important factor in this lab. F is equal to k q1 q2 by r squared, where k is the coulombic constant, q1 q2 are the charges, and r is the distance of separation, and F here is the electrostatic force between two different charges. And similarly, gravitational force, where F is equal to mg, which acts downwards on the object, again about negative y-axis, is another important factor. So gravitational force is experienced by each tape, and when the charged object is floating, it's in equilibrium, which means the gravitational force is equal to the electrostatic force. Now, experiment and procedure. We model the charged tapes as point charges and as line charges in two different models. The assumption is that the tape is a point charge in the first model, and the second model assumes that it's a line charge. The arrow resistance is ignored, and both tapes have the same charge. This is an assumption which we make. And then the procedure is you create a base tape and paste a U tape on top of it, and then remove it quickly. Now the U tape is observed for interactions with negatively charged pen, neutral book, and charged U tape. Similarly, we suspend a U tape on top of height, and then we observe its interaction by bringing another charged U tape below it. We note the distance of repulsion. We see that the tape was attracted to a neutral book. The tape was also attracted to a charged pen, but the charged tape repelled another charged U tape. This shows that the charge obtained by the tape is positive charge. We also see that the distance of repulsion is 0.0232 in meters. Modeling and results. The first model assumes that the tape is a point charge, and the second model assumes that the tape is a line charge. Both models are created using GlowScript, and as we can see in the first model, the model assumes that two spheres represent the point charges. Arrows are used to show the gravitational and electric forces. And by equating them, we are able to calculate that the value of the force of gravity and electrostatic force is 1.68 into 10 power negative 3 Newton. The charge on each tape is 10 power negative 8 coulomb. The electron deficit is 6.26 into 10 power 10 electrons, and there are about 5.46 into 10 power 6 electrons per atom. The upper tape acts as the system, and the surroundings include the lower tape and the rest of the room. We also note that the orange arrow represents the electrostatic force, while the green arrow represents the gravitational force. In the second model, 30 different particles, all lined as a line, are used to model the tape. Now, this calculates the infinitesimal charge and the force exerted by these infinitesimal charges and adds them up to calculate the net electric force, as well as the gravitational force. This is the model that we use, and we find that the gravitational force has a value of 1.67 into 10 power negative 3 newtons. However, the charge has a value of 2.24 into 10 power negative 8 coulomb, which is 2.23 times greater than the value that we calculated from model 1. The system and surroundings remain the same, where the upper tape is the system and the lower tape and the rest of the room are the surroundings. Discussion. The sources of error are mainly the fact that the tape might be humid, the room might be humid, the conditions might have led to loss of charges, as well as the fact that the charges on the tapes may not be equal. Now, what if electrons had a positive charge and protons had a negative charge? Well, the law of electrostatic always holds true, which means like charges will still repel. However, the electric field would now be inward instead of being outward. Now, we see that the model which we used as line charges for the tapes had a different value than the first model. This is because the line charge clearly uses 30 different particles and evenly distributes the charge. This is more accurate, and hence the actual value is probably closer to 2.23 into 10 power negative 8 coulombs for the charge tape. Conclusion: we are able to observe and analyze the interaction between charge clear tips, and we are able to simulate this as a model in GlowScript and calculate different values. Thank you.